Okay, I'd like us to take a look at another circuit problem here. What we're asked for is to find the current in the 4R resistor. So just have a look at that. This is a pretty simple circuit, um, and but I'm not going to simplify it. I'm not going to change it right now. The first thing I'm going to do is find the battery current. So you might want to know why I'm interested in the battery current. The battery current is not the same current that flows through the 4R resistor here. But I'm interested in the battery current. And here's why. Here's my plan for this circuit. And that is, if I can find the battery current, then I can find the potential drop over the 2R resistor. I can find the potential drop over this resistor and the R resistor. And if I find the drops over those resistors, then I can find the elevation across the three resistors that are wired in parallel there, the 3, 4, and 5 resistors. And that's what I want to find. So actually, the first thing I'm going to do is, just as far as analysis goes, I'm going to think about this in terms of potential. So let me do a little bit of highlighting here. And I'll start by highlighting the positive terminal. Here's positive terminal, my battery. So that's the very highest elevation in my circuit. And then I need like a middle elevation. So I don't know, I'll use pink for that. This is some other height here. I need another color. I'll use green over here for this elevation. And then I have a final elevation. So I have a total of 4 different elevations or potential values in this circuit. So if I find what red is, right, the idea here is if I can find these elevations, if I can define them, figure out what they are, then I can actually find the current anywhere in this circuit. And that's the method I'm going to use. So I start by, it's fairly simple for me here to find the battery current. So I can do that, right, by just simplifying the circuit. So if I take the 3R, 4R, and 5R resistors, those are clearly in parallel. They have the same potential difference. So those are in parallel. 1 over that parallel there is going to be 1 over 3R plus 1 over 4R plus 1 over 5R there. So once you do that math, I'll leave that to you to do, and you can see more details in the written solutions. That parallel resistance there is equal to 60R over 47. Okay, don't go to decimal approximations. You hear me say this all the time, and I'm going to keep repeating it. Don't do that. So just, figure out your fractions. You guys can all do this. So once I have that then simplified down, that's those 3 simplified down. So what that would look like, I'm just going to do a real quick sketch, is that would be that 60R over 47. And then I still have the 2R and the R, right? Here. And then my 12E battery. So now this is just 3 resistors in series. So I can pretty easily find my R equivalent for the entire circuit. That's going to be just the 60R over 47 plus 2R plus R. And that will give me 201R over 47. Okay, so now I have the equivalent resistance. That means I can find my battery current. In my notation, I have special notation for battery current in a circuit like this because it's like the primary current. It's an important current. It will be the greatest amount of current in this circuit. That current will split up to go to the other branches, but will have the greatest value through the battery. And I like to keep an eye on that in my math. So I'll call that I naught. That's going to be then just the EMF divided by the equivalent resistance, right? So that's going to be 12E multiplied by 47 over 201R, which gives me 564E over 201R. Okay, so now I have the battery current. I'm going to erase this circuit, the simplified circuit down here. I just wanted you to just have in your brain. It's really good to draw those intermediate values. I just don't want to use this space for that anymore. All right, I have my battery current. So now my job is to find the drops over those two resistors. So the drop over the R resistor, here's the notation I'm going to use. I'm going to use V sub R, all right? And that's going to be the drop over this one right here, okay? So that's just going to be the current that's running through it, which is the battery current. It's wired in series with the battery, multiplied by its resistance, which is R. So that means that the drop over that resistor there is just 564E over 201. And then the drop over the 2R resistor, right, that's this V2R that I'm finding there, is going to be, again, battery current, which is what flows through that resistor, multiplied by its resistance, which is 2R. And so that just gives me 2 times 564 E over 201. And don't be afraid of these values. Just write them out so that you don't lose track of them. It's fine to use parens or like do what makes sense to you, but be sure you don't lose stuff. Okay, so I have those two drops. So that's awesome because that means that now I can figure out exactly what the elevation is for the red and the green, right? So here we go. If I call the blue down here, and this is at the negative terminal of the battery, so I can call that 0 volts here. That's going to be my reference there. That's going to be 0. Oh, actually, this is symbolic. So I'm just going to call that 0. I don't use units for something that's symbolic. If that's 0, then up here, the yellow, obviously at this battery, I just climbed up 12E. So the elevation, the yellow elevation is going to be 12E. Got it. Then I drop down as I'm going through this 2R resistor. I'll draw a little arrow in there, right? My I naught current is going to be going through that resistor and it'll drop there. So the red potential is going to be equal to 12E minus the potential drop over the 2R resistor. Okay, because that's exactly what's going to happen at that resistor. We're going to drop how much? We just figured it out. We figured it out right down here in the drop over the 2R resistor. So I can now figure out exactly what the height is at for the red. And then if I'm interested in what this green is here, right, because I want the difference between red and green, the green is just going to be 0. Now, when I cross this resistor R, remember that current is flowing this way through this resistor. It's flowing from left to right. So if I go from 0 from blue to green elevations, I'm actually going to be climbing up the stairs over resistor R because green elevation is higher than blue. Blue is lower. So you got to be popping this out, seeing this in 3 dimensions. Each of these resistors is, and the battery, those are all sets of stairs here. So as I'm moving from blue to green, I'm going against the current and therefore up the stairs, must be going up the stairs to green. So the value at green then, how big are the stairs? Well, that's what V sub R is. So the value at green is simply V sub R. All right, so the difference then between the two, so that will be, let me change colors here. The potential difference over the 4R resistor is then going to be basically red minus green, right? It will be red minus green. So what will that look like? It'll be 12E minus potential 2R, that's red, minus the green. Green is potential R elevation. Okay, so that is what I'm interested in. And that will help me find my current, right? Once I have the resistance. So once I have the potential difference, I have the current. So here, this is just going to be 12E minus This is 2 times 564 E over 201 minus 564 E over 201. So that's going to kind of simplify it in a cute way. And what I end up getting here, I'll make a few different moves, but what you end up getting here is 240 E over 67. So that's the potential difference across the 4R resistor. And then once you have that, you can, I'll change my colors up again here, but then to find the current through the 4R resistor, that's just going to be the potential difference across the 4R resistor divided by its resistance, which is given as 4R. So that will end up being that 240 E over 67, and then we just divide that by 4R. And here we end up with 60 E over 67R. And that is our current through the 4R resistor. So this is, it's a sort of a potential focused way of solving the problem, but it is solving a problem this way through analyzing potential is always going to be the strongest way to solve a problem when you can do it. So I highly, highly recommend it.